Hi everyone, I'm Paulo Lacerda. I'm Cloud Solution Architect at Microsoft Global Customer Success Team, and I'm here with Richard.
So hi, I'm Richard Healy. I'm an Enterprise Cloud Solution Architect for Azure and Microsoft. And today I'm co-presenting with Paolo for the AgentOps Monitoring Governed Agents in Production with AgentOps webinar. So hi. We'll get straight in because I'm going to start the session and time is precious. So in this session, we're going to be talking about the central question for teams building AI agents today. Not how to build the first demo. We already know how to do that. The question is harder. Can we safely ship this agent, and where is the evidence? That's what this session's about, the operating model we call AgentOps. It's how we take the production engineering discipline we've already trust for traditional software, and we apply it to AI agent. Where behavior is probabilistic, tools have side effects, and yesterday's safe answer might not be the safe answer tomorrow. We've got 6 content blocks to cover today, plus there'll be demos as we go. So here's how we've structured the session. First, AgentOps Foundations. This is the introduction to why AI operations need a new discipline, what the 4-pillar operating model looks like, where the teams feel they sit today in terms of their maturity. Then we'll go a bit deeper into the 4 pillars themselves. Evaluate, that's the release signal that tells us whether a new version is actually better or just different. Ship, the gates, approvals, and evidence that turn that signal into a release decision. Observe, once the agent is live, how we see what it's doing through traces, metrics, and feedback. Operate, running the agent over time. Instant response, model lifecycle. And we'll close on adoption and your next steps. How to start on Monday morning with one agent running and operating with confidence. Don't hesitate to put questions in the chat as well as we go. We'll start with foundations. So before we talk about evaluators, pipelines, dashboards, we want to spend a few minutes on why do we need any of this? Why isn't traditional DevOps good enough for agents? What changes? What happens when an agent has ability to call the tools, hold memory, and make decisions on its own? Is it the same? Let's find out. Teams can stand up a generative AI prototype in days, but getting to production is a different story. That gap is what we call the production gap. Here's the contrast. On the left, we've got a prototype. It works. On the right, production needs proof. A prototype is a one happy path demo. The product owner watched it, answer 3 questions correctly, and said, yep, let's ship that. But production needs repeatable evaluation across dozens of hundreds of use cases. So a prototype gets a manual quality check. Production needs release evidence. Something you can show to a security reviewer, a compliance officer, that says this version was tested against these criteria and it passed. A prototype is a single version snapshot. Production has version models, version prompts, version tool definitions. All these change. A new model ships, the prompt gets edited, a tool's API changes, each one shifts behavior. We have to know what we shipped and when. And the classic, it looked good last week. That's the most dangerous sentence in an agent development. Agents are probabilistic. The model can drift. The data behind retrieval can drift. User behavior changes. So yesterday's confident answer becomes tomorrow's hallucination. So how do you demonstrate that auditability? Well, the bottleneck's moved. It used to be, can we build the first demo? Now it's, can we prove the next version is safe to release? Without the operating model in place, every change is a fire drill. Does this need a new operating discipline? Why can't we just use the DevOps practices we already have? The answer's in this table. As we move up, every tier adds a new operational surface. At the bottom, simple prompts. We send a question, we get an answer. The trade-offs are quality and cost. It's manageable. Next tier up, add retrieval augmented generation, RAG. Now we think about grounding, retrieval quality, data freshness, and permissions. Did the user have access to that data that inform the answer? That's what we need to find out. Next up, tools using agents. The model is calling functions, planning steps, each with side effects and auth boundaries. The blast radius of a wrong action gets much bigger. And then single agents with memory. Multi-step traces become the units of behavior. A bug might emerge on the 7th turn because of something remembered from the 3rd. And then at the top, multi-agent systems, orchestrators coordinating sub-agents, emergent behavior. The point is that even simple agents put you several tiers above where DevOps practices were designed for. Multi-step plans and tool calls multiply the failure surface. So snapshot testing is not enough. We need a new type of cadence and evidence. We need a platform that orchestrates all these components, and that platform is Microsoft Foundry. We'll clarify positioning here because this comes up in every conversation. Where does Foundry fit, and where does AgentOps fit on top? Think of Foundry as the control plane, 3 layers. The services layer there you see is now how teams interact. You've got the portal, the SDK, you've got the CLI and REST APIs, and then GitHub Actions as well. It's the same control plane, different ways in. The capabilities layer is really where Foundry, what it does for agents. It manages agents and versions. It's built in evaluators for quality, groundness, fluency, coherence. It's agent-specific evaluators, so intent resolution, task adherence, tool call accuracy. It also hosts the AI red teaming agent backed by Pirate, which is the Python risk identification tool, and that's for testing safety, security, and responsible AI. It supports OpenTelemetry and tracing natively, and it integrates with content safety for runtime policy checks. And lastly, the third layer is the runtime layer, where all the agent executes and integrates to other Azure deployments and services, including Azure AI projects, model deployments, tools and MCP servers, plus integrations to application insights and log analytics. So AgentOps, it's not a replacement for any of this. It's the operating model that connects Foundry signals to release decisions and day 2 action. Foundry is the source of truth. AgentOps is what we do with that truth to ship safely every time. How do we know when a version is safe to ship? So the production readiness checklist answers these questions. And this is a slide you want to take particular note of. It's the release evidence contract for any agent you're about to put in front of users. There's 7 things on here, so we'll run through. Number 1, target and versions are explicit. We know exactly which agent, which version, which prompt, which tools we're releasing. Number 2, an evaluation data set exists and thresholds are agreed. Minimum quality, groundness, intent resolution. Below these, the release stops. 3, we've got the CI/CD gate. It actively blocks regressions. It's not advisory. If evaluation drops, the pipeline fails. Number 4, telemetry and traces are wired. We've got application insights collecting. We've got open telemetry spans flowing. We've got trace IDs end to end. 5, we've got safety and red team findings are tracked. The red teaming agent has run at least once before release. Number 6, release evidence is reviewable. Not in someone's head, it's in an artifact attached to a release. 7, we've got owners know what to do when signals fail. There's an on-call, there's a runbook, a triage flow. It turns, I think it works, into we have evidence for this release. Every section that follows now fills out 1 or more items on this checklist. We've done the checklist, 7 items that tell us the evidence a production release needs to contract. So how do we produce that evidence repeatedly, every release without heroics? That's what the agent operating model provides. It's got 4 pillars: evaluate, ship, observe, and operate. Everything we talk about lives inside one of these 4 pillars. The first, evaluate, and this includes data sets, rubrics for scoring, red teaming, thresholds for the decision to proceed or not to ship. We've got a curated golden data set of representative user journeys. We run the current and candidate versions against it. We measure quality, groundness, latency, cost, intent resolution, tool call accuracy. We don't ship blind. Secondly, we have got ship. The evaluation result becomes a gate in the CI/CD pipeline. If quality drops below threshold, the pipeline fails. If safety regresses, the pipeline fails. We promote with evidence, human approvals, environment promotion, and a canary rollout where model, prompt, and tools are versioned together. A fail gate is the strongest moment in the model. the point at which a bad version stops before users ever see it. And thirdly, we've got observe. Once in production, we need traces. We've got the full chain, prompt, plan, model call, tool call, retrieval, safety event, latency, cost, and user feedback. We use Foundry observability and application insights together, correlated so that the same trace question answers across release, runtime, and evaluation. And fourth, we've got operate. This is where we operate the agent over time. We diagnose root cause from traces and evaluators on production samples. We run the incident runbook. We manage model lifecycle, cost, and capacity. And then we review traces from production. They become new rows in the evaluation data set. So the next evaluation tests against everything we've learned. So people, process, and platform are the key to all the success of this operating model. People mean the agent is owned. There's an on-call runbook and reviewers. There's people on call. Process means we follow the 4 pillars for every change. And platform means Foundry is the control plane with telemetry traces, evaluators, and pipelines all wired together. The output is release evidence and operational confidence. But now we're getting to understand the operating model a bit. The question is, where do you think your team sits today in terms of maturity against this? The checklist defined what good looks like. The operating model tells you how to get there. In terms of where you are on that journey to what that good looks like, we'll do a quick self-assessment of where you think you might place your team right now on that journey. And for that, we use the maturity model. There are 4 levels. We expect those people to be somewhere between the first 2. So be honest. Level 1, the initial. So ad hoc demos, you're doing manual evaluations. Someone types 5 questions, looks at it and goes, yep, that seems fine. There's no gates, logs are scattered. And if you ask the team to explain a regression from last week, they can't. So level 2 is more defined. Prompts are versioned, agents are versioned. There's a pre-prod evaluation data set. CI builds artifacts. The team can answer, what's the current version? What do we test it against? That's the minimum bar for any agent going in front of real users. Level 3, managed. And if you get here, you're doing well. Quality and safety gates in the CI. Continuous evaluation on production. Runbooks and SLOs, service level agreements, service level operations. And this is where most enterprise customers want to be within 12 months. And level 4, optimized. You're doing drift and cost guardrails. You're doing canary plus also rollbacks. The feedback flywheel is real. Every review production trace talked about goes back into a new evaluation row within hours. So I'll pause here to let you have a think, because as to where you might think you fit onto this model. And as you're having to think about it, we're next going to show you what a model looks like as a reference architecture and using Foundry and Azure, so a bit more technical. So for this, I'll be handing over to Paolo to introduce the reference architecture.
Thanks, Richard. AgentOps architecture. This picture is the bridge between the operating model and the real implementation. So instead of reading it box by box, let's follow one agent version as it moves from idea to production. It starts on the left in the inner loop. This is where the team is still learning. The Sandbox Foundry project is the safe place to design the agent. The instructions, the tools, the model choice, the knowledge source, and early behavior. The developers work in VS Code or Copilot CLI using a framework like Microsoft Agent Framework or LangGraph when they need orchestration or MCP tools. But the important point is, even if the inner loop, the agent is already treated like a version product. The prompt, tool definitions, configuration, CI workflow, and evaluation evidence, they all live in source control in GitHub or Azure DevOps. That means the agent is not just something configured in the portal. It's something the team can review, compare, promote, and roll back. Then the agent candidate moves to the right side, operationalizing. This is the outer loop, where we can stop asking, does it work on my machine? And start asking, do we have enough evidence to promote it? Continuous delivery moves the same candidate through dev, QA, and prod. Each environment has its own Foundry project, and because each environment has a different purpose, that is shared development. It's where the team run manual tests, quality evaluation, and safety evaluation quickly. QA is where the bar gets higher. We add integration tests, red team, coverage, and the release evidence package. And between QA and prod, there is a gated approve. The gated approval, that approval should not be a rubber stamp. It should be a human looking at the evidence and deciding whether the version is ready or not. When the agent reaches prod, the goal changes again. Prod is about safe rollout. Smoke test, blue-green or canary rollout, and controlled exposure. Prod is where we prove the rollout is healthy and where we watch real user behavior carefully. Now, look at the runtime choice across the environments. The same pattern works whether this is a prompt agent managed by Foundry, hosted agent running as a container through agent service, or a bring your own compute runtime on container apps or AKS. That matters because AgentOps should not depend on one runtime shape. The operational model is consistent. Version the agent, evaluate it, gate it, observe it, and feed production learning back into the next version. At the bottom is the control plane that keeps the loop connected. Foundry gives us the operational view, overview, assets, compliance, quota, trace, and evaluations. Application insights and log analytics hold the detailed telemetry, and Azure Monitor turns the important signals into alerts. This is where a trace from production becomes more than a log line. It tells us which version ran, which model call happened, which tool was invoked, and what latency and cost look like, and whether there was a safety or quality signal. The dashed feedback loop is the most important part of the diagram. Production is not the end process. Production teaches the next evaluation set. A failed trace becomes a regression case. A safety event becomes scenario where team can check latency or cost. Issue becomes a release criterion. That's AgentOps loop on Foundry. Creates, evaluate, promote with evidence, observe in production, and improve the next version from what we learn. The first item on the checklist, probably the most important one, is evaluation. The eval dataset, the thresholds, the release signal, that's where we go next. Evaluation strategy. 3 stages of evaluation across the whole life cycle of the agent. Stage 1, base model selection. Before we write the agent, we pick the model with evidence. We test the candidates against the representative dataset. We measure cost, latency, and quality on the actual use case. We choose with evidence, not excitement. Stage 2, pre-production evaluation. The candidate version runs against the golden dataset with built-in evaluators. We get scores, we compare against the previous version and against absolute thresholds. If we pass, we promote it. If we fail, the regression has to be diagnosed before anything ships. The golden dataset does not need to be huge. A few dozen careful choose case tied to a real user journey beats zero case by an enormous margin. Foundry built-in evaluators cover quality, groundness, coherence, fluency. The agent-specific evaluators, intent resolution, task adherence, tool call accuracy, critical if the agent calls, functions, or follow multi-steps plans. Stage 3, post-production monitoring. We keep evaluation. We sample production trace. We run them through the same evaluators. We watch for drift, quality drops, new failure modes. The interesting trace, regressions, weird tool calls, new behavior, they become new roles in the golden dataset. The dataset is alive. Don't wait for the perfect dataset. Start with 20 case, catch our first regression, and add the following case as a row 21. That's how the team start to trust the gate. Quality and safety are different signals. A quality score tells you whether the answer was coherent, grounded, and useful. It will not tell you whether someone could jailbreak the agent, it revealing secrets, or trick it into sending a malicious email. Those are different problems with different test case and a different cadence. found ships with an AI red teaming agent backed by Pirate. Instead of ad hoc adversarial testing every 6 months, we automated on a schedule. 4 risk categories. First, harmful content, hate speech, violence, things the agent should refuse no matter how cleverly someone asks. Second, jailbreak, prompt injection, role hijacking, getting the agent to ignore its system prompt. New techniques come out every month. The red teaming agent maintains a library. Third, hallucination, ungrounded claim, fake citations. The adversarial framing is different from quality. We're asking, can we trick the agent into making things up? Fourth, data exfiltration, PII leakage, secrets echoed back to abuse, especially important if the agent has access to internal system cadence, pre-release gate, schedule weekly, and post-instant. Finding feed straight back into the evil dataset. A jailbreak that worked once becomes a regression test. Next time, we catch it before users do. One more piece announced at Build 2026, adaptive evaluation paired with Assert framework. Assert stands for Agent Security and Safety Evaluations Runtime. The idea, take your governance policy and automatically convert them into eval test case. Instead of handwriting every adversarial scenario, the platform generates tests from your policies. Quality says the agent is good. Safety says the agent can't be abused. Both have to pass. Now, how do we enforce these signals? That brings us to the ship pillar and CI/CD gates. I'll walk you through a golden dataset run on Foundry, the evaluator scores, and how the release signals is produced. Evaluate really comes down to one question. Is the agent good enough to ship? Before any deploy, AgentOps turns that judgment into measurable, repeatable gate. So let me walk you through how I build it, starting with the data. First, I'm creating a small, honest data set. I open the file in the editor and write 3 travel prompts, Lisbon, Seattle, Tokyo. Then I pair each one with the answer I expect. Those expect answers are my contract with the gate. With that data set in place, I write up the gate. I start with a quick pre-flight that confirms my config is valid and the Foundry evaluators are ready. Coherence, fluency, text similarity, response completeness. Then I run the AgentOps eval init, and it generates my evaluation recipe. It declares the agent, the dataset, the prompt, the model, GPT-4o mini in this case, and one config ties the whole gate together. Then I run AgentOps eval run. It delegates to Azure AI Foundry, writes the result in a report, and it comes back with the verdict. Threshold stats passed, the same data set, same evaluators, so the gate is consistent and auditable run after run. But that smoke gate is just my floor. A real traffic is messier than a few single-shot prompts. So I evolved the data set into conversational-aware roles, 3-day Lisbon food trip, a low-budget Seattle weekend, a family Tokyo plan with 2 kids. Then I had an rubric. Instead of one blunt score, I described what a great answer looks like, and Foundry custom rubrics evaluator turns that into a weighted name-it criteria. Correct itinerary, adherence to constraint like kids and budget, clear and honest notes. And here's the part I love. Every run comes back as a per dimension scorecard. It scored 0.92, and I can see exactly why. The itinerary passes, the practical notes scores as like lower, each with a written reason from the judge. It's explainable, not just a single number, and the rubric is in my project. Quality is only part of the shipping safely, so I add 2 more gates, and I scaffold both with GitHub Copilot. First, I ask the AgentOps skill to write up assert against my agent. It's installed the package, writes the config, and runs determinist safely checks. Prompt injection, PII leak, jailbreak, generating its own adversarial test case, and scoring each one. Then I do the same for red team. Same GitHub Copilot skills, scaffold, a runner, and Azure AI evaluation attacks my agent across the real risk categories: violence, hate, self-harm, using strategies like base 64. My attack success rate comes back at 12.5% under my 20% gate. Finally, one command package all of it, the evals, the safety checks, the red team runs into a single advanced pack I can hand to my security partner. And that's the heart of evaluate, answering can we ship it and how do we know? With evidence instead of opinion, a few honest examples became a full gate, a weighted quality rubric, assert safety checks, and adversarial red team run. Every threshold, a version in my repo, and package into one evidence pack I can hand to an approver. Next challenge is making that gate run automatically. We have evaluation, we have red teaming, we have a golden data set. Now we need to turn all of that into a release decision. This is the ship pillar, pipelines and gates, CI/CD for agentic AI. The pipeline pattern looks familiar: build, evaluate, gate decision, deploy, but the contents are agentic specific. Build means we package the agent, the model version, prompt template, tool definitions, configuration, all versioned together as a single artifact. If the prompt changes, behavior changes. If the tool definition changes, behavior changes. We need a single thing we can roll forward or roll back. Evaluate is the stage we just covered. The candidate runs against the golden dataset. The red team agent runs. The evaluator produces scores. The result is an evidence pack, eval report, red team report, content safety scan, dependency check. Gate decision is the moment of truth. Are scores about thresholds? Did red team find anything new? Is cost within budget? If all yes, the gate passes. If any no, the gate fails. The strongest moment in the whole pipeline is a failed gate. That's the moment a bad version was about to reach users, and instead of, it just stopped it. 3 kinds of gates: PR gates, block bad prompts before merge, fast, lightweight on every pull request; deploy gates, block bad versions before the next environment, full eval suite on every promotion; watchdogs, scheduled checks against production; catch drift, tool failures, upstream model chains. Each gate produces an artifact for the audit trail. When compliance asks, how do you know this was safe? You point to the artifact. And this extends beyond CI/CD now. The agent control specification, ACS, referenced during build 2026, it defines 8 interception points in the agent's runtime: startup, input, pre-model call, post-model call, pre-tool call, post-tool call, output, and shutdown. Policy is evaluated at each point as code. It works across Foundry, Microsoft Agent Framework, and LangChain open source under the Agent Governance Toolkit on GitHub. Think of it as a CI/CD gates that follow the agent in production, not just at deployment time, but on every single request. GitHub Actions or Azure DevOps pipelines either works, the pattern is the same. Let me show you a failed gate in action. A prompt chain triggers the pipeline. The evaluator scores a drop below threshold, and the gate blocks the deployment. That's the strongest moment in the model. Evaluating locally is only half the story. So now I make those gates run automatically on every pull request, on every deploy. Let me show you how I write that up end to end. Now I turn those gates into CI, one command, and I get 2 GitHub Actions workflows, a pull request gate, and a dev deploy. But those workflows still need to be in Azure, and wiring that up used to be a weekend project. OIDC, federated credentials, secrets, environment variables. With Copilot CLI in my workspace, it's one prompt. It reads the AgentOps skill, verifying my role assignments, create an Entra app with a federated credential, and wires the OIDC variable straight into my dev environment. No long-lived secrets in the repo, no manual ClickOps in the portal. My repo and Azure are now connected, and the pull request gate is armed. Here's my first real pull request, a simple prompt change. The PR gate kickoffs automatically. It staged the candidate, run the same eval recite I just showed you, and neither greenlights the merge or blocks it. This one passes, so I merge to main and dev deploy workflow take over. It reevaluates the merge candidate in dev, records the deployment, and the workflow run URL. This is my provenance. From one line in the record, I can answer what is in dev right now, who shipped it, and when, and which eval allow it. Non-documented knowledge, no spreadsheets, no guessing what shipped. And that's what ship really means in AgentOps. The same gate I built locally now runs on every pull request and every deploy with OIDC instead of secrets, and a tiny manifest file as my single source of truth for what is live. The next challenge is seeing how that agent actually behaves once real users arrive. Pipelines and gates are the release time part of the model, but the operating model does not stop at release. This is the observe pillar. We need to see what agent is doing in production, trace, correlation, and the closed loop. Observability is more than monitoring. This distinction matters. Monitoring asks, is the service health? Is the endpoint up? Is latency within target? Those questions matter, but they're not enough for an agent. Observability asks a different question. What did the agent do, and why did it do it? Not it responded in 100 milliseconds, but what was the prompt? What tools did it call? What documents did retrieval surface? What safety events fired, and what was the chain of decisions? For agents, the unit of understanding is trace, not at any point status. The founder observability stacks has three pillars. Pillar 1, tracing. OpenTelemetry-based spans across the agent execution, covering model calls, tool calls, retrieval steps, and safety-related events. Everything is correlated through trace IDs, visible in Foundry, and flowing to application insights and log analytics for deep analysis. Pillar 2, monitoring. The classic signals, latency, error rate, token throughput, resource health, still important, just no longer enough on its own. Pillar 3, evaluation. Continuous evaluation, the evaluators running on production samples, quality scores on real conversations, grounded checks on actual responses. The eval pipeline is now also a runtime signal. These three stack. Continuous evaluation gives you macro health, monitoring gives you service health, tracing gives you the explanation. The required signals, prompt, plan, model call, retrieval, tool call, safety event, latency, cost, user feedback, release version, the required correlation, trace ID, session ID, agent version, deployment, eval run, incident, owner. Without correlation, observability is disconnected at dashboards. With it, the same trace answers questions across release, runtime, evaluation, and day 2. Correlation turns observability from dashboards into operational signal. This is the connective tissues line for the whole session. Telemetry is not the goal, action is. Let's walk through it signal by signal. Latency spike, the trace shows a tool call taking 10 times longer than baseline. Azure Monitor fires an alert. The on-call looks at trace, sees the tool timing out, disables it, fall back to a manual path, the agent stays responsive. Tool error rate climbs. 30% of calls are returning 500s. Disable the tool, the agent gracefully degrades, users still get value. Safety violation. Content safety blocks a response containing personal data. The trace is captured as safety incident open. The reviewed trace goes into the red team dataset. Next release, the exact attempt is part of the regression suite. Eval scores drop. Continuous evaluation shows quality on a particular intent. Drop it from 0.92 to 0.78 below threshold. The canary pause, a ticket opens, we diagnose. Cost anomaly. Token usage on a tenant triple overnight, APIN, throttles, FinOps gets notified. We figured out it's a legitimate adoption or an attack. Positive feedback, a user gave a thumbs up on a trick question. That trace gets sampled into the eval dataset as a positive example. Every signal triggers a concrete operational response. Every response feeds back into the eval dataset, the gates, or the runbook. This is how observe feeds operate and how operate feeds the next evaluate and ship cycle. The closed loop. That's how we keep getting better release after release. Let's look at the real trace. I'll show you the trace waterfall correlate spans across model and tool calls, and how a signal fires an alert and feeds back into the eval dataset. Once my agent is live, the gate is not enough on its own. I need to see what exactly it does in production. So now I turn on the telemetry layer and let me walk you through every request and every score in real time. Now that my agent is live, every request becomes a trace. Each row in the trace tab is one conversation with duration, token counts, an estimated cost, and the evaluation scores attached. I can sort by cost, filter by agent version, or click into the full waterfall. The same observability surface I would expect for a service applied to my agent. The operate page is my live view. Prompt shoot alerts on my left, my agent inventory, the cost trend, the success rate, and Ask AI on the right for natural language questions across everything I see. This is what I put on the on-call wall, one screen, all my agents, end to end. And this is where evaluation becomes a loop, not a one-off. An interesting trace, a failure, an edge case, a high cost outlier, I can promote it to my eval dataset with one click. 15 rows here with lineage track back the original trace. My next gate is tighter than today's because it includes what production actually did. And it's all open telemetry under the hood. Every eval score lands in log analytics as a GenAI.evaluation.result. So I can write the KQL I read no, average coherence by conversation per hour over the last 24 hours, no vendor lock-in on my data. My existing dashboards keep working. And that's at the heart of Observe. Every conversation becomes a trace, every eval score becomes telemetry. An interesting trace feeds straight back into my eval dataset. Production is not a black box, it's the next iteration of my gate. The next challenge is what happens when something does break and how I prove the release is still safe to ship. The model runs every day after launch. This is the operate pillar. Day 2 operations, running agents in production, where most of the actual work lives long after the launch demo. Day 2 is where most of the operational reality lives. The hard part is not getting the agent to launch. The hard part is keeping it useful, safe, and reliable on day 90, day 180, day 365. 4 concerns on the quadrant, and they are interlocking. Reliability and SLO, availability, latency, error rate budgets. When a downstream tool fails, does the agent gracefully degrade or fall over? Tools dependency mapping matters. Agents often have 5 or 10 tool dependencies, each with a potential failure mode. Incident response, severity classes, runbooks, on-call rotations. When an agent misbehaves, we need a sequence and not improvisation. Containment first, advanced bucket fix second. Model lifecycle. Model gets deprecated, new ones come out, prompts evolve, tools change. Every one of those is a release. Every release needs the same gates and evidence. Cost and capacity, PQ versus pay-as-you-go, token budgets per tenant, tool call budgets, alerts on anomalies. Increasingly important as agent moves into business-critical workflows where a single noise user can spike a 6-figure bill. One more thing worth naming here, Microsoft Agent 365 went generally available in May 2026 as the enterprise governance umbrella for agents. 3 pillars, observe, govern, secure. The SDK is free and framework agnostic. It works with Microsoft Agent Framework, OpenAI Agents SDK, LangChain. The point, whether you build your agent on Foundry or bring it from another framework, Agent 365 gives it one place to see every agent in the tenant, enforce policies, and audit what they did. It pairs with Defender for runtime detection and Purview for data governance. That's the two-day governance layer that sits above individual agent implementations. These concerns are connected. An incident feeds a reliability roadmap. A model change runs through the same gates. A cost anomaly triggers an incident. If severe enough, everyone feeds back into evaluation. Let's go deeper into the two concerns customers struggle with most. When something goes wrong in production, the runbook turns a fire drill into a sequence. The severity table sets expectations. S1 critical. Safety events or data leak. First action. Stop gate. Roll back to last known good version. We don't investigate first. We contain first. S2 high. Quality or grounding regression. Planned rollback or version pin. Give ourselves time to diagnose without users seeing degraded behavior. S3 medium. Latency degradation or cost spike. Rate limit. Investigate, then act. We don't roll back yet. We measure, identify, decide. S4 low. Drift indicator on a single metric. Schedule analysis in the next eval cycle. Wonder if it worsen, escalate. The triage flow. Detect, the alert fires, correlate trace, find the trace ID, the conversation, the version, the environment, identify version, what was deployed, what changed, contain, apply the first action from the severity table, stop the bleeding, analyze, why did it happen, what evaluators do we run, fix, implement the change, reevaluate, the fix passed the gate, same as any other change, we don't ship fixes on a fast lane, close the evidence, post-mortem to the artifact, failing case to the eval dataset, runbook updated if needed. Every closed incident makes the operating model stronger, the eval dataset grows, the gate criteria tighten, the runbook gets tailored, build it, use it, update it after every instance. Model lifecycle is the second pain point every customer right now is having it in this conversation. The model we depend on is being deprecated. A new model came out, the vendor changed terms. What do we do? The answer, same gates, same evidence as any other release candidate. Treat every model chain as a release. Triggers, deprecation, new model availability, cost of performance pressure, vendor change, the canary process. Step 1, pin the current model as the baseline, exact version, exact deployment, exact configuration, pin it. Step 2, run the new model against the eval dataset offline, same dataset, same evaluators, two models side by side. We see where the new one is better, where it's worse. Step 3, promote to canary traffic slice, 5%, real production users, real conversations. Step 4, compare live quality, cost, latency, and safety against the baseline. The canary slice produce trace. We run evaluators on those traces. Step 5, roll forward or roll back with evidence, quality scores, cost comparison, safety findings. It's not a good call, it's evidence-backed. Ownership, the AI platform teams coordinate the infrastructure, the application teams validate against their use case, both sign off. With evolves and a release contract in place, model changes become routine, not a crisis, just another canary, backed by evidence. For this last demo, I'll show a regression caught at PR time, a one-line reverse that hardens the gate and a release blocked by production signals. Shipping is the easy part. Operating is where the real work begins. Now I'm moving to day 2 operations, catching regression before they reach users, and providing release readiness with evidence and not opinions. Let me show you both flavors of blocked. Here's how it goes wrong. I open a pull request with a prompt added, well-intentioned, look fine in reveal. The PR gates runs the same eval recipe and reports a regression coherence drop. Similarly, drops, threshold fails, my release evidence flips to blocked. AgentOps health check shows the criticals on screen. Regression coherence, regression similarity, latest evaluation failed. The bad prompt never reached main, never reached dev, never reached my users. It was actually caught by an evaluator and a gate and not by a customer complaint. And the postmortem writes itself because every step is durable in Git and in the action log. My fix is one-line revert. I restore the non-good prompt push and rerun the same gate on the same dataset. This time everything is green, coherence 5.0, similarity 4.667, every threshold passes. And here is the part that matters most. That bad prompt is now a permanent row in my regression dataset. The next time someone touches that area of the prompt, this is exact failure, has to pass again before the gate lets it through. The incident hardened my gate. That's the AgentOps loop. Every regression I catch, make the next one harder to ship. That regression was caught at pull request time. There is a second flavor of locked I will hit once I'm in production. I run the same gate against the slide agent, and the rows themselves pass, but AgentOps, looking at the production telemetry, still blocks the release. The criticals here are not quality, they are latency, P95 in production, and the error rate in production. Same command, same gate, completely different signal. The evidence pack captures both, so my release reviewer sees the full picture in one file, not 5 tabs. And for day-to-day visibility, I look at the AgentOps cockpit. Every finding has a fix, the recommendation that links back to the exact source. So I do not just see that something wrong, I get the concrete next step. Across the bottom, error rate at 0%, P95 across 11 seconds, 5 workflow runs, 80% success, latest PR passed. Same evidence as the markdown, but interactive. This is what stayed open on my second monitor. And that's the AgentOps story, end-to-end. I evaluate before I ship. I ship through gates that run on every pull request. I observe what real traffic actually does, and I operate the agent the way I operate any production service, with regressions caught at PR time and a release reviewer who sees evidence, not opinions. Every loop close back into the next gate. The bar moves up, never down. With that, I finished my demo and going back to Richard.
Well, thanks, Paolo. That was fantastic. Great demos. And that is AgentOps end to end. Paolo just walked us through the 4 pillars in motion: evaluate, ship, observe, operate, and how they reinforce each other into a single operating loop. Combine that with the foundations we open with, the building blocks, Foundry is the control plane, the operating model, and the maturity ladder, you have the full picture. A repeatable way to move agents from it works in demo to we can run it in production safely and prove it. Which brings us to the question you must be asking, and it's the right one to be asking: what is my next move? Well, you've seen the pattern, you've seen where the evidence lives and how the gates hold. The gap between watching this session and living it is one deliberate step. And we're not talking about a 12-month program here or a big platform bet. We're talking about something much simpler. So let me show you what that looks like. So you don't need to boil the ocean. We're going to close with a practical path for you to take away. Set a goal of one agent, operating it safely, and give that target a timeline of 30 days. Follow these steps. Pick one agent. I'll repeat, one, not your portfolio. One agent that's close to production today with a real owner, real users in pilot, and real business value. Step 2, evaluate it. Define that release criteria and a small evaluation data set. Minimum quality, groundness, no new harmful content findings. Build that data set, even if it's just 20 cases. Use real user journeys, real edge cases, real mistakes the agent has made before. And step 3, ship it. Add the PR, the deploy gates, and the readiness evidence pack. The evaluation runs on the PR, it runs on deploy. The gate blocks if the scores drop. The first time a developer sees a failed PR, because it's an evaluation regression, you know it's working. Step 4, observe it. Wire telemetry, traces, dashboards, and alerts. Applications, insights is all connected. Open telemetry spans are flowing, and at least one dashboard, at least one alert for the worst case failure mode. It doesn't have to be perfect, but it just has to exist. Step 5, operating it. So review the evidence weekly, have a 30-minute meeting, walk through evaluation reports, the safety findings, the incidents, what's going into the data set. The rhythm is what makes it stick. And step 6, feed production learnings back into that next evaluation cycle. Reviewed traces become evaluation rows, post-mortem findings become regression tests, red team findings become adversarial coverage, and the data set grows. The next gate becomes stronger. And finally, step 7, revisit that maturity model when you've done it. Identify where your team sits today. Where did you put yourselves? Set a goal, a concrete goal to reach the next level within 90 days. And that's how you build the momentum. 30 days, 1 agent, 4 pillars. You'll have moved your agent from it works in testing to we can operate it safely. You'll have run the improvement cycle end to end. You'll have the pattern that scales across your portfolio without reinventing every decision. That's your next move. Pick the agent, start the loop. We can help you with the rest. That brings us to the end of today's session. So I just want to say thank you very much for spending the time with us today. And AgentOps is not something you buy, it's something you build, one agent at a time. Just remember that, one release at a time. We'd love to help you take that on that journey and support you along the way. On behalf of myself and Paolo, we just want to say thank you for your time today, and we'll see you in production.